Okay, so welcome back, and actually we can use this whole idea of this rotation for this particular function, right, as our um, as a model for something that happens in the real world. And I think this is a neat one. Let's say you've got this bicycle tire, and this particular bicycle tire is the kind of tire that turns in such a way that we could model the height as a function of t, right, which is the arc length. Remember that we were talking about arc length right here. Uh, 12 times the sine of pi times t plus 12, where t is the time in seconds since the start of rotation. All right, so what would that mean to us? Well, if we think about the situation this way, it might help. At time t equals 0, what have we got? Well, if we substituted it into our function right here, we would find that h of 0 is the same thing as saying 12 times the sine of pi times 0. Well, that's just 0, by the way, plus 12, right? So, well, 12 times the sine of 0, what was the sine of 0? Well, remember that on our unit circle, wrapping function, this was equal to 0. So we get 0 plus 12. And so this is 12 inches. So what would that mean to us? Well, if I'm looking at my bicycle tire right here, 12 inches above the ground, I'm going to assume that this is pretty much what this means. This mark right here would be at the 12-inch mark above the ground here. And so at time t equals 0, I'm thinking to myself, well, okay, 12 inches is right here. What's going to happen as we go down the line? Well, if we were to keep on going right here, right, what we're saying is that, well, as our tire turns, right, we know that it's going in a cyclical way. So what's going to happen is let's let this tire go for, oh, I don't know, let's make it t equals 1/2 of a second. What's going to happen? Well, at 1/2 a second, I'm here, right? Here on my tire is at 0 seconds. So right here I'm at 1/2 of a second, and if I let it spin around, I'm at 1 full second, right? And then if I go 3/4 of the way around, I'm at uh, uh, here, right? This is at 3/4 of a second. Or, no, this is 1/2, so this is 3/2 of a second, or 1.5 seconds. And then at right here, 3/2 at 1 full second. Sorry, at 2 seconds, I'm right here, right? So it takes me 2 seconds for this tire to turn all the way around. Now, how did I know that? Well, here, let's take a look at some numbers, right? If I were to say, let me put this in purple right here. If I were to say 2 seconds, let t equal 2 seconds. How do I know this? Well, at t equals 2 seconds, that means I've got h of 2 pi, 2 seconds, is equal to 12 times the sine of 2 pi. But what happened at 2 pi? Do you remember? Well, at 2 pi, we said that the sine would be the same as the sine of 0, because we're back at the same place, right? So, here we are. At 0 and at 2 pi, we said we were at the same place, and so that's equal to 0 right here. So let's use that, right? This is going to be 12 times 0 plus 12, which is to say we're back at 12 inches again. So now we've got an interesting question right here in part B. Part B asks us, well, how high is the point after 3.5 seconds worth of turning? Well, 3.5 seconds is kind of like saying 3.5 seconds is kind of like saying what is the height at the time we were at 7/2 seconds, right? Well, if I look at the way that I've associated my height right here, we said at 1/2 second we're getting a quarter of a turn. So if we're going 7 halves, that means we're going 7 quarter turns. So what does that mean? Okay, 1, 2, 3, 4, 5, 6, 7 half turns. Does that make sense? Well, h would be equal to 12 times the sine of pi times 7/2 plus 12. That's equal to 12 times the sine of 7 pi/2 plus 12. 7 pi/2. Well, let's get that coterminal positive angle between 0 and 2 pi to find out. If we subtract 2 pi away, that's 7 pi/2 minus 4 pi/2. That's 3 pi/2. Now, if we go back to our wrapping function, the sine of 3 pi/2 was right here. That's -1. So we're taking 12 times -1 plus 12. Our height at 3.5 seconds is 0 inches. So I know that I'm in this particular place right here at the bottom of my turn if I've gone 7 half turns. Get it? So in 7.5 seconds, I'm down here at this point, 3 pi/2. So I've gone to, and this would be a model for this tire as it rotates about its axis right here. Okay, interesting application, more to come.